Today's video is going to cover the distributive property. This is a review video for most of us. We know what the distributive property is and we know how to use it. You'll see in a little bit exactly why we're covering this again, but for now what I want you to pay attention to is this new graphic organizer for notes. So I'm going to explain how the graphic organizer works. So in the middle you see the distributive property. So in the middle you'll see the key concept of the lesson, and then each of the corners represents a different part of that concept. So in this upper left we've got the definition of the concept. In the upper right we've got a fact or a recall about the concept. And then in the lower left we've got an example or examples that represent the concept. And then we've got in the lower right non-examples or common mistakes that relate to this concept. So the definition of the distributive property is when you multiply something through parentheses. So you can see below in this example, this is like the math definition that they gave you with all letters. You can see that they're multiplying this A through the parentheses. Normally we would add and then we would multiply according to the order of operations, but the distributive property is like an amendment, or it's like a new rule to the order of operations, which allows us to multiply before we do what's in the parentheses. So we're multiplying to everything in the parentheses and we get a new expression that is equivalent. It's also important to note that the distributive property is not just multiplication. It can be applied to division as well. You can see here we have an expression x plus 2 divided by 4. Now there isn't any parentheses, but you could put parentheses around x plus 2 because we know that we would add first and then divide. So we could go ahead and just put those parentheses there. And if we wanted to distribute the 4, we could distribute the 4 here and distribute the 4 here, but we're dividing. So it looks like this when we do it. So we've got the x divided by 4 plus 2 divided by 4. It's the same exact idea, but with division. So let's turn our attention to the examples down here. We've got two different examples. We've got one that says simplify the expression and one that says simplify the equation. So when we simplify the expression with the distributive property, we're looking for what is being multiplied or what's on the outside of the parentheses with no operating sign between it. Well, this 4 right here, but it's not just a 4, it's also a negative 4. We got to make sure that we include the sign that's in front of the number or the variable that we're distributing. So when we distribute this 4, or negative 4, sorry, into the parentheses or through them, we get a new expression that is equivalent, meaning that they're equal expressions. They're the same expressions, just written differently. And that new expression is 5 minus 4x plus 8. We got that minus 4x plus 8 from our distribution. Negative 4 times x is minus 4x. Negative 4 times negative 2 is plus 8. Now we can also use distribution in solving equations, and that's really why we're relearning this. When we solve equations, we know how to solve, we know the process for solving, but what we're going to learn how to do is how to justify in solving. We're going to learn how to justify, or what properties are we using to solve. So you can see here we need to solve for x. The first thing we're going to look to do is to simplify. So we're going to simplify by distributing, and we can distribute this positive 3 through the parentheses to everything inside, and the resulting equation is negative 37 equals negative 1 plus 3 times 3 is 9 x. 3 times negative 3 is a negative 9. So you can see now that we've got a new equation, but it's the same exact equation, just written differently. Well, what's the justification for writing this new equation? What did we do that was different, or how did we go from here to here? Well, all we did was distribute. So anytime you perform a new step on an equation, you've got to give a justification. So our justification for now on this first step is distribute, or a distribution, or you could just put a D. Now if I'm going to finish this off, the next thing I'm going to do is I'm going to look to simplify before I start solving. So I see that we've got a negative 1, we've got a negative 9. I can simplify a negative 1 and a negative 9. This is called combining like terms. So negative 1 minus 9, and I'm going to go ahead and, use the calculator for this. So we got negative 1 minus 9 equals negative 10. And it doesn't really matter if I write it in front of the 9x or behind it. So I'm going to write 9x and minus 10. How did we go from this equation to this equation? What's our justification? Well, we just simplified or combined like terms. You can use two different justifications for that. And now these last two steps that we're going to perform, I'm not going to give you justifications because we'll learn about what those justifications are in a later lesson. So we're going to use inverse operations now to solve for x. We've got the 9 that's being multiplied and the 10 that's being subtracted. Let's go ahead and start with the subtraction. We're going to add. These are inverse operations. And I've got to make sure I do it to both sides. So when we add the 10 to the right side, we get 0. So those are gone. We got 9x plus 0, which is just 9x. And we can combine our like terms here. So we've got negative 37 plus 10. And that gives us a negative 27. And now for our last step, we can go ahead and divide. So we can divide by 9 since it's being multiplied, and I know you can't see, but we've got negative 27 divided by 9. So we can go ahead and just divide it by 9. And we get a negative 3. So we know that in this equation, negative 3 equals x. So if I put that number back in to the original equation, the number that I get for both sides should be the same if I solved and justified my steps correctly. Now I want to turn your attention to this right corner, the non-examples. Here are the two biggest things that we see students do incorrectly when distributing. They'll see an expression or expression that looks like this, negative 2 plus x plus 2, and they'll think, oh, this negative 2 is being distributed to the parentheses. Now this is very different than what we had over here where we had the 3 parentheses 3x. There was no operating sign between. Here you have an operating sign between. You've got an add sign. So this negative 2 is not being multiplied, so you cannot distribute. This is a non-example because you cannot distribute something that's being added. The second one, the second common mistake or non-example we see students make is when they distribute only to one term in the parentheses. So you can see here, if we were to distribute correctly, we'd have to take negative 2 and multiply to x and to 2. But in this example, all they did was they took negative 2 and they multiplied it to x, and they forgot to multiply it to that second term. So that's also a non-example. Make sure you get all of this down. If you have to pause the video, that's fine. And then repause it to go over the rest of the examples. So here we have simplified the expression. So that just means distribute. That's the only thing that we can do here to simplify. So we've got negative 3 times 2, that's a negative 6. Negative 3 times positive 3 is a negative 9, times x is x. And we can go ahead and just leave it like that. If you wanted to use the commutative property, you could commute the negative 9x in front of the minus 6 or negative 6, and you would get negative 9x minus 6. Solve the equation. This will be the last example today. So negative 3 times 2, negative 3 times 3. We're going to simplify first. So our new equation is negative 33, sorry. Negative 3 times 2 is negative 6. Negative 3 times positive 3 is a positive 9x. What did we do? Or what was our justification? We distributed. Our next step, there's nothing more that we can simplify on either side, so we can go ahead and use inverse operations. I'm going to start with eliminating the negative 6 by adding 6 to both sides. Here we get 0. And then on this right side, or left side, sorry, when we combine like terms, we got negative 33 plus 6. That's going to give us a negative 27 equals 9x. And then we can go ahead and solve for x by dividing the right side by 9 and dividing the left side by 9. Here we have 9 divided by 9, which is just 1. 1 times x is just x. And on the left side, when we simplify, we've got negative 27 divided by 9, which is a negative 3. So we don't have justifications for this step or this last step yet, but we'll learn those as we go through these lessons.